Okay, so applying the theorems that we had previously, let's have an example. So given that line TV is parallel to line WY with transversal line RS, the measure of angle RUV is x plus 4 times x minus 3, and the measure of angle WX is x squared minus 3. Let's find the value of x. Okay, let's have our solution. In the given figure, we know that angle RUV and angle WXS are alternate exterior angles. So let's put it here. Angle RUV and angle WXS are alternate interior angles. Exterior rather. They are alternate exterior angles. And since they are alternate exterior angles, in the previous theorem, we know that angle RUV is congruent to angle WXS. Okay? And by the definition of congruent angles, we know that the measure of angle RUV is equal to the measure of angle WXS. Okay? So in the given, we know that the measure of angle RUV is x plus 4 times x minus 3 is equal to, and we know that the measure of angle WXS is x squared minus 3. Okay? So using the FOIL method, you can multiply x by x, x by 3, 4 by x, and 4 by 3. Okay? So that the product would be x times x is x squared, and x times 3 negative is negative 3x, plus 4 times x is 4x, so negative 3x plus 4x is positive x. Then 4 times negative 3 there is minus 12. Is equal to x squared minus 3. And then subtracting both sides of the equation by x squared, they can cancel out x squared already since they are equal to 0. What remains is x squared, so rather x minus 12 is equal to 3. And by subtraction, this implies that x is equal to 15. Okay. I'm sorry, it's not 15. So this one should be negative 3 plus 12. So x is equal to 9. Okay. X is equal to 9. Natuling lang. Okay. Now, let's substitute. Determine whether the value of x is will give us the correct measure for each angle. So we know that the measure of angle RUV is equal to x plus 4 times x minus 3. And we know that our x is equal to 9. Okay, so just plug in the value of x. We have 9 plus 4 times 9 minus 3. We have here 13 times 6, which is 78. Okay, and for the measure of angle WX, which is equal to x squared minus 3, then just plug in. This is 9 squared minus 3, which will give us 78. Okay, therefore we can conclude that the measure of angle RUV is equal to the measure of angle WX, which is equal to 78, and our answer is correct. Okay, next. So in the given figure 2.10, line R is parallel to line S, and our transversal is line L. The measure of angle 3 is 4x plus y, and the measure of angle 5 is 6x plus 5y, and the measure of angle 6 is 5x minus 2y. Let's find the value of x and y. So first things first, let's establish the relationship between the angles. We know that angle 3 here and angle 5 are interior angles on the same side of transversal. Okay, and we can also see here that angle 5 and angle 6 form a linear pair. So basically angle 3 and angle 6 they are actually angle 3 and angle 6 as well as are alternate interior angles. Okay, since they are alternate interior angles, then they are congruent. Okay, but we can also say that the measure of angle 3 and the measure of angle 5, they are both same side interior angles, so their sum is 180. So let's stick to that. Angle 3 and angle 5 are interior angles on the same side of the transversal. Okay, of the transversal. So therefore, since that's the case, we know that in the previous theorem, the measure of angle 3 plus the measure of angle 5 is equal to 180. And by substitution, we know that the measure of angle 3 is 4x plus y plus the measure of angle 5 is 6x plus 5y is equal to 180. And simplifying the expression on the left, we have here 4x plus y, removing the grouping symbol, plus 6x plus 5y is equal to 180. Combining similar terms, then we have 10x plus 6y is equal to 180. And let's call this one as equation number 1. Okay? Next, on the other hand, we can say that angle 5 and angle 6, okay, form a linear pair. Okay, form a linear pair? Well, actually, if we are to use as well the measure of angle 3 and the measure of angle 6, it also arrive at um, the same answer. Okay, so what in here I'm going to use the idea of linear pair. Okay, so we can see that angle 3 and angles 3 rather angle 5 and angle 6, angle 5 and angle 6 form a linear pair. And since they are a linear pair, we know that the measure of angle 5 plus the measure of angle 6 is equal to 180 by the definition of linear pair. And by substitution, we know that angle 5 is 6x plus 5y plus the measure of angle 6 is 5x minus 2y. 5x minus 2y is equal to 180. Okay? And simplifying the expression on the left, by removing the grouping symbol, we have 6x plus 5y, okay, plus 5x minus 2y is equal to 180. Combining similar terms, what we get is 11x plus 3y is equal to 180. And let's call this one as equation number 2. Okay. So we can see here that equation 1 and equation 2 are systems, okay, of linear equations in two unknowns. And to solve for the systems of linear equations in two unknowns, we have four methods to use. We have, number one is substitution. Substitution. We can also have comparison. We can also have by elimination. And of course, by Cramer's rule. Okay? So for the sake of recall of your lesson in college and advanced algebra, let's use all these methods in solving for the value of x and y. Okay? So let's have by substitution first. Okay, by substitution. So that we are going to look first for the value of one variable in terms of the other. So in this case, I will be using equation number 1. So equation number 1 is 10x. So 10x plus 6y is equal to 180. And let's solve for the value of y in terms of x. So that I will be subtracting both sides of the equation by 10x. What I have here is 6y is equal to 180 minus 10x. Then dividing both sides by 6, then therefore y here is equal to 180 minus 10x all over 6. Okay, I will no longer simplify, but I will be using this to solve for the value of x. Okay, now, so using equation number 2, that is 11x plus 3y is equal to 180. Okay, and we know that the value of y is equal to 180 minus 10x all over 6. That's the initial value of y in terms of x. By substitution, we have 11x plus 3 times 180 minus 10x divided by 6, okay, is equal to 180. Okay, simplifying further, if we know that we can cancel out 3 and 6, this becomes 2 and this becomes 1. What we have here is 11x plus, I have here, then I can divide already 180 and 2. I have here 90 minus 5x is equal to 180. Okay, and simplifying further by removing the grouping symbol, what I have here is 11x minus 5x is equal to 180 minus 90. What I have is 6x is equal to 90, and therefore this implies that x is equal to 15. Okay, now let's solve for the value of y. So solving for the value of y, so what I will be doing here is to use for the equation wherein we initially solve the value of y in terms of x, that is y is equal to 180 minus 10x all over 6, and the value of x is equal to 15. Then just plug in 180 minus 10 times 5 divided by 6 is 180 minus 50, 15 rather, the value of x is 15, so this is 150 all over 6. What I have here is 30 all over 6, and the value of y is equal to 5. Okay, therefore the value of x is 15 and the value of y is 5. But let's check if these values are the correct value of x and y respectively using the second method, which is by comparison. Okay, so by comparison, so in this case we're going to compare the two equations in terms of their similar variables, or equal variables rather, using the transitive property of equality. Now, so since in equation number 1, okay, we know that y is equal to 180 minus 10x all over 6. Okay, let's solve for y in terms of x in equation number 2. Okay, so our equation number 2 is 11x plus 3y is equal to 180. So 11x plus 3y is equal to 180. And then subtracting both sides of the equation by 11x, what I have here is 3y is equal to 180 minus 11x. Then dividing both sides by 3, therefore y here is equal to 180 minus 11x divided by 3. Okay, This is the initial value of y, or the value of y in terms of x. Now, so by comparison, we know that y is equal to y because they are the same variables. But we know that the first value of y is 180 minus 10x all over 6 in the first equation. And the value of y in the second equation is 180 minus 11x all over 3. Okay? Then multiplying both sides of the equation by the least common multiple of the denominator, which is 6. Multiplying both sides by 6. Then what we have here is 180 minus 10x is equal to 2 times 180 minus 11x. What we have here is to distribute 2. We have 180 minus 10x is equal to 360 minus 22x. And combining similar terms, what I have here is 22x minus 10x is equal to 360 minus 180. What I have here is 12x is equal to this one is 180, and therefore we know that x here is equal to 15. Okay, and solving for the value of y. So to solve for the value of y, either you use the first equation, the y in the first equation, and the y in the second equation. But since we already have used the y in the equation number 1 in our substitution method, let's use now the y in the second equation. Okay, just to verify if it will still provide the correct answer. Okay, or the same answer. Y is equal to 180 minus 11x all over 3 there, and then the value of x is equal to 15. Then let's have 180 minus 11 times 15 divided by 3. This is 180 minus 11 times 15 is actually 165 divided by 3. Then let's have here 15 all over 3. Then the value of y is equal to 5. Then we know that our answer is correct because of the two methods that we use, the same answer we get. Okay, but we will not stop here because we're going to use another method, which is by elimination. And again, I am doing this for the sake of review. Okay, so by elimination means we are eliminating a variable using the additive inverse idea. Okay, so for equation number 1, that is 10x plus 6y is equal to 180. So 10x plus 6y is equal to 180. This is our equation number 1. And our equation number 2 is 11x plus 3y is equal to 180. This is our equation number 2. So let's say for this presentation that will eliminate, okay, the value of y. So how do we eliminate the value of y? What do we do is to multiply both sides of the equation of equation number 2 by negative 2. So we say here, and then we add it to equation number 1. So we say that equation number 1 plus negative 2 times equation number 2. Okay, so that would be 10x plus 6y is equal to 180. And then negative 2 times equation number 2 here is negative 22x minus 6y is equal to negative 360. Okay, and then let's add them. So this would be negative 12x is equal to negative 180. Okay, then dividing both sides by negative 12, what we have here is x is equal to 15. Okay, and then solving for the value of y, I use let's say equation number 2. So 11x plus 3y, but you can also use equation number 1. 3y is equal to 180 at x is equal to 15. Okay, so we have here 11 times 15 plus 3y is equal to 180. 11 times 15 is 165 plus 3y is equal to 180. And then subtracting both sides of the equation by 165, we say that 3y is equal to 180 minus 165. Dividing both sides, simplifying, we have 3y is equal to 15, and dividing both sides of the equation by 3, we can cancel this one, then y is equal to 5. Okay, and notice that our answer is still the same. Okay, last, we're going to use by Cramer's rule. Okay, by Cramer's rule. Actually, this one is a topic of linear algebra, and later on we will discuss this as well. But for this presentation, let's just review. Okay, so basically we have the general form. Okay, the general form of the system of linear equation as a sub 1x plus b sub 1y is equal to c sub 1, and a sub 2x plus b sub 2y is equal to c sub 2. Okay, so that to solve for x, okay, to solve for x, for the value of x, then we're going to use this formula. So x would be the coefficients of c1, c2, b1, b2 divided by a sub 1, a sub 2, b sub 1, b sub 2, and we're going to get the determinants, which is actually, if you simplify this is b2 times c sub 1 minus b sub 1 times c sub 2 divided by a sub 1, a times b sub 2 minus a sub 2 times b sub 1. Okay, so just plug in. We know that our equation number 1 is 10x plus 6y is equal to 180, and equation number 2 is 11x plus 3y is equal to 180. So that a sub 1 here is 10, and then b sub 1 is 6, c sub 1 is equal to 180, and also a sub 2 is equal to 11, b sub 2 is equal to 3, and c sub 2 is equal to 180. Okay, just plug in. So b sub 2 is 3 times c sub 1 is 180 minus b sub 1 is 6 times c sub 2 is 180 a all over a sub 1 is 10 times b sub 2 is 3 minus we have here a sub 2 is 11 times a sub 2 is 11, b sub 1 is 6. Okay? Then simplify 3 times 80, 180 rather, is 540 minus 6 times 180 is 1080 all over this is 30 minus 30 minus 66, okay, which is negative, this one is negative 540 divided by negative 36, which is 540 divided by 36 is 15. Okay, and we still get the same answer. That's the value of x. Next, for the value of y, to solve for y, so we're going to use the formula y is equal to let's have here c sub 1, c sub 2, a sub 1, a sub 2 all over a sub 1, a sub 2, b sub 1, b sub 2. Okay, let's plug in. This would be a sub 2, c sub 1 minus a sub 1, c sub 2 all over a sub 1, b sub 2 minus a sub 2, b sub 1. Notice that the denominator of the determinant in x is the same as the denominator the determinant of y. So just substitute a sub 2 is 11 times c sub 1 is 180 minus I think our formula is a sub 1 is 10 and c sub 2 is, wait, I'm going to fix our formula. So this would be a sub 1, a sub 2, c sub 1, c sub 2. Okay, so that this would be a sub 1, c sub 2 minus a sub 2, c sub 1. Okay, so by substitution, a sub 1 is 10 times c sub 2 is 180 minus a sub 2 is 11 times c sub 2 is 180, a divided by, I have here a sub 1, b sub 2 is 10 times 3 minus 11 times 6, which is 1080 minus 1980, okay, all over 36 minus 36, okay, which is negative 180 all over negative 36, and therefore the value of y is equal to 5, and we got the same answer. Okay, so in the next video we'll try to prove lines to be parallel. Okay.